Well, all right, let's get started. Uh, Again, I want to welcome everyone who's joined us today, and will continue to join us as we get going. I'm Preston Canada. I'll be moderating this RBI Roundtable webinar. As we go through the presentation, all attendees will be muted, but we do want forum-style questions, so please submit your questions in the comment section, the chat section. And we'll read off some of the questions and bring them up as we're going. So please add your comments and questions. Well, I'm going to start introducing our panelists. I'll start with Chase David. Chase is a director of NDT technology here at Gecko Robotics. He's been in the NDT industry for the past 10 years. He has extensive knowledge and experience working with clients to improve mechanical integrity programs with a special focus on RBI implementation. Next is Jose Aparicio. Jose is the NDT technology manager here at Gecko. He's also a metallurgist engineer and an ultrasonics inspection expert for refinery, petrochemical, and process industries. For the past 15 years, Jose has advised industry titans on asset reliability by participating in over 80 turnarounds. He is able to provide a great technical perspective and non-destructive testing evaluation. Last, I'd like to introduce Quinn Holub. He's our business development manager here at Gecko Robotics. He has been with the company for over 2 years and has 2 years of robotic inspection experience, specifically specializing in rapid ultrasonic grading with innovative technologies. Quinn also has a degree in construction science and management and is working with our oil and gas industry team to continue and educate around industrial robotics platforms. So let's get right into it. What is risk-based inspections and why is that approach appropriate, Quinn?
Yeah, let me kick it off a little bit here. So the big idea, as the way I see it, the big idea behind risk-based inspection is really prioritizing your inspection efforts, both your investments in time and your investments in budget, by evaluating the equipment within the context of its risks. There's a lot of factors to consider here, but what do we know about the asset? What do we know about its current state? What do we know about the probability of failure and the consequences of failure? But this is something of a deviation from the tradition of time-based inspections, and it really helps focus the asset owner's efforts where it's most needed.
Jose, what is your perspective on RBI since you've been on the side of the fence as a owner operator representative and also a third-party inspection consultant and testing engineer?
So yeah, risk-based inspection for me, it's it's to know where the equipment is going to actually potentially give some it's going to hurt to the clients, to the refineries, and as Quinn mentioned, it's a lot of factors involved, but most of them it's actually productivity, and fatalities. So we always have to have that safety factor there, and the monitoring for those vessels and piece of equipment there, and that's risk-based inspection for me.
Yeah. Being mostly always in the sales side of this business, I think what I would say is my perspective of dealing with clients would be to simple it down to sales speak. It would be using blanket guidelines and time-based inspections. You end up inspecting everything more equally than you should. When you start analyzing and looking at inspection data and your risks, you can target things that need further investigation. So something that may be dangerous or process critical versus something that's not process critical and not dangerous, you don't inspect at the same rates. So that's the way I understand it as a non in the weeds technical type person. Am I kind of right in that sense? Like, I want to kind of communicate my opinion because my opinion is kind of the dumbed down version of it. Is that like a layman's term of it?
I heard it said a while back that 10% of the assets require 90% of the attention. And, you know, that ratio is certainly debatable, but I think it makes a great point as far as what's deserving and what's going to be the best use of that a limited amount of client budget and time.
Yeah, that I've heard that before. That makes sense. So Chase, how could some of these robotic advanced UT techniques with the idea of thinking of RBI, how do they fit into RBI programs?
Sure. I think robots are really enabling us to do things that weren't possible before, and in respect to doing internals, doing 100% surface area inspection, looking for general or localized corrosion. Now you have the opportunity to either do that through robotics internally or externally, in using something like Gecko Robotics rug tool to look for general corrosion or isolated localized corrosion. And then we have rapid AUT as well, which is, it's a mixture of what the industry's had in the past with a nice evolution of adding phase array and mechanizing the phase array application with a robot. And that's kind of what the trend is moving towards for the future, is more dense data and higher productivity. And we're seeing that with the rug application and rapid AUT.
Gotcha. Jose, you've been around inspection and robotics for a little while now, and you definitely know ultrasonics very, very well. How do you see that the robotic platform is the superior way in some inspection applications?
It's because, you know, the way how the clients, you know, the way how the industry wants those samples of RBI from piece of equipment, you know, they're always hard to reach. They're always hard to get, you know, that samples they want. And, you know, the matter of the fact that the robot can go there and in an unassisted way to get data and gather that data for the future assessment, it has very value, you know, it's valuable for them. So what we're facing right now, the technology is so fast, and you know that, you know, unintrinsically that type of inspection unassisted there for client, it's extremely well for them. So I think that's the, yeah, one thing the RBI has also, it's like it needs the assessment, it needs more data from previous inspection, you know. So in order to create that RBI assessment, you need previous history from the vessel, you know. So if you don't have that, and then now you rely on those robots to gather more data for you, you know. So that's how I see it.
If I could jump in there, Preston, if I could jump in there, to emphasize on that, robotics, I believe, are really opening the door to getting higher confidence scores than you were otherwise, you know, had the ability to do, either through access or true budget. So now scaffolding a whole tower is maybe the norm today, but if you consider robotics to do that external inspection, maybe you can go out and get a much higher level B or a level A confidence score assessment through gathering much more data than was practical before.
Gotcha. So
Thank you, Chase. I was going to bring up confidence actually as the one word that defines our comfort level with the coverage and the methodology for finding the damage mechanisms that we're anticipating. So I think it's a great way to frame the benefits of new robotics and new automated inspection techniques for sure.
Right. So a couple of the answers that overlap with the idea that access is a huge advantage with robots. So you have a robotic platform that can climb and get to areas that you couldn't get to unless you had rope access, scaffolding, or some other way. Well, I don't know many other ways besides that, but some way to get there. So the robotic platform access is allowing you to inspect areas that you have not inspected, possibly the same way before with the same coverage or same cost structure, because cost is always a factor in these decisions. But are there applications where access is, let's say access is not the main winner for a robotic platform, is there consistency in data coverage, data density gains on assets you can reach at ground level, for example, over conventional methods?
Yeah. So in respect to RUG, I think when it comes to general or localized corrosion as a tool to go out and get massive surface area, maybe a few thousand square feet of surface area in any given 10 or 12-hour shift, a really powerful tool to go out and screen the material. And otherwise you wouldn't have been able to do that, through, like you said, things you do have access to, maybe that's something you could do, but productivity wise, it's not something that's really conducive to budgets. So with that tool, you can really get out there and you can really cover a lot of surface area really quick. And then when it comes to like more MIC or isolated corrosion, things that you're, very, very fine corrosion, we have now, the ability to take what used to be handheld tools and put them on robots. So phased array applications can now be put on robots and used in a practical manner to go out and get 500, 800 square feet in a given shift and screen for things like MIC or isolated pitting and things like that. So those tools are going to become really powerful in the future.
Right. And then environmental cracking, those other applications as well, the data density, just increases all the ability to detect and to make positive calls.
Yep.
So let's like break it up on that, because that's a lot of topics based on all of the wall loss or environmental damage. Well, how do you see robotics fitting into just specifically wall loss damage RBI programs? What are some of the benefits and the drawbacks? If there's got to be drawbacks, right? There's got to be something, but we talked about some of the major benefits. Well, let's talk specifically wall loss. If you were going to tackle a wall loss inspection challenge, how would you think about it with robotic platforms? I guess, Chase, you've been designing these things. What do you think? How would you look at it?
Sure. I think it's a really good way to think about how we use GOAL today in a piping scenario. So today we use GOAL to shoot, let's say 50 to 100 feet in each direction, and we screen in a qualitative way to look for areas that we need to do manual UT. Today, robotics enable us through like the RUG platform to go screen that piping. We can screen roughly 700 to 1,500 linear feet of piping, depending on diameter in a given shift. And with those tools, we can now get a quantitative data set instead of a qualitative data set. With that, it becomes really powerful that you're able to get data all the way throughout that asset, throughout that area. It becomes a really productive tool.
Gotcha. So if you compare, Quinn, do you have that graphic where we have the scale that shows RUG versus AUT versus rapid AUT? A lot of people know what AUT is. Well, AUT, in the sense, like AUT is a big term, but most people use the term for corrosion mapping. So automated ultrasonics corrosion mapping. RUG, which we've been talking about, is rapid ultrasonic gritting. That's a platform with fixed transducers put on sleds, driven in straight lines, taking readings as they're going.
Right. Yeah, I think
the rapid AUT. Can you talk just a second on that, Chase, how you would think about that in this graphic?
Sure. In respect to the two platforms, I'll sum them up real quick. RUG, like you said, has many transducers that are fixed on the front of the robot, and they are not mechanically rastered, is the best way to explain it. They're fixed, and then we drag them across the surface, and that becomes our rastering motion. Is the forward motion is now the inverse of what is traditional AUT corrosion mapping. With traditional AUT corrosion mapping that are common off-the-shelf systems, you can put one transducer on there or maybe two, and you can raster it mechanically to get that index of the Y index in this case, and then you can move forward indexing every quarter inch or so to get a data density of roughly a quarter inch by 50 thou or 100 thou, something like that. And that's representative here on the far left, where your overall production, because of that indexing, trying to overlap that probe, becomes somewhere in the 100 to 150 square feet range, as it's shown there in that graph. And then with RUG on the far right, because we're not mechanically rastering those probes, we're dragging them across the surface. The production rate is anywhere from 3,000 to 5,000 square feet in a given shift. And today we have apparatuses for those sensor sleds that are now 1/4 inch by 1/4 inch. And we're getting readings 10 to 25 times per linear inch. So we're getting readings that are comparable to traditional AUT with just a much higher production rate.
Okay. So this is between these technologies, there's reasons to use each one depending on the application, speed, size, I guess what damage you're looking for. If you're looking for some sort of generalized corrosion, then in a big surface area, the RUG would be your best bet.
Sure.
Rapid AUT would be where you'd want to look at finer type pitting or blistering or
Sure.
mid, like you mentioned. Quinn, when you're talking with people in the industry, how do you see people looking at this?
I think the big deal with RUG, or the quickest way to summarize what RUG means to the clients that are using it, is it is a slight compromise on the data density, but it's going to let you map out the entire piping circuit rather than just doing some sampling or some spot checks or getting a percentage of that piping circuit. So you're going to be able to do the entirety of the job and collect quantifiable data across the entire job or across the entire asset for, without compromising on, generally at a same or cheaper price point, and for usually less logistics and logistical cost and time than you would for an AUT solution. When you're comparing it to a manual sampling, I think the difference is even more stark because we're looking more in the range of 300 thickness readings per square foot as compared to hoping you get lucky with your manual readings and putting a large margin for error on the data set ultimately at some point. So
right. So you have your damage mechanism you're looking for, whether it be localized corrosion or generalized corrosion or isolated corrosion and pitting. So everyone built their RBI tables based on the guidelines, but then tailored them and tweaked them as they desired to run their program. As new technologies like rapid AUT come out, does that kind of change how people should schedule their confidence scores? Because AUT has been the top dog for a long time on corrosion mapping, and did a fantastic job, but it still has that point-by-point variance that's much higher than rapid AUT. I guess I'm a little naive to like how things adjust with new technologies, but how would you see that adjusting, Chase?
This is a difficult question to ask because every owner user operates their RBI program a little differently. But I think it all starts with the damage mechanism review and understanding each individual unit and each individual asset and where you're going to hone in on where to apply these technologies. And then second, you really need to know how confident are you in these NDE techniques that you're employing and the procedures that are being put in place for those NDE techniques. So, how well are we screening with those techniques? So all that has to be kind of brought into account, but I do think there's been a major shift with not only the NDE principles and technologies that have come out in the last 10 years or so, but the practicality of actually applying them in the field has really changed in the last 2 or 3 years. And today we have tool sets that didn't exist 10, 15 years ago that are really, really powerful for going out and getting much more surface area grab, but also at a much higher data density. In respect to like environmental cracking applications, or just to start with the the general corrosion applications, we're looking at about a 50x difference in production here, but we're also looking at something like 10x on data density between rapid AUT and AUT. It's a huge difference there. But it's about 5x speed increase there between rapid AUT and AUT, with a 10x on the data. And then RUG has about a 50x production factor, but you lose a little bit of that data density, which you sacrifice for that production, but then you hone in somewhere else on it. But in respect to going into like environmental cracking and using other techniques and applications for that, there's been a huge shift in there, applying phase array techniques to environmental cracking where it didn't exist before. And in those realms, you're looking at a 25x density increase that wasn't there prior.
That's pretty huge. So with the idea of that higher increase of data density, let's stick with corrosion, and then we'll move it into environmental cracking on this concept. But the higher data density, this question is going to be for you, Jose, because I know you followed up other inspectors on tough calls that they had to make, and you've had to have people follow up on you to prove what you found, because a lot of times you find something that's very, very critical and very, very costly. So second opinions come around just like you would go to a doctor for a second opinion. Jose, how would you feel about having rapid AUT data density 10 years ago instead of now just having access to it? Like, what do you think the real advantage of that data density is going to show out?
Yeah, like 10 years ago, we didn't have the technology to do a quick analysis and ask for that machine, to give us more density of data. So we didn't have that, and we didn't have technology about also probes. That hardware wasn't there in order to increase that amount of data that we need in order to make a right call. Yep. So, but I think what we're seeing now, when we put the robots on the table, that we can get areas that they were impossible before. If they don't shut down the equipment or shut down the unit. Right now we have that technology and the robot part just to get there, to get that critical area. So RBIs always, they ask for a certain percentage of samples, but a lower the percentage is, so your data should be the most critical area to inspect, in order to find something. So that's the most thing that I've seen with clients. Like, they have 30% of well inspection and base metal, but where they choose that sample because they didn't have robots before. Now they didn't get the right sample for them in order to find the damage mechanism. Right now, we can actually suggest them, hey, it's good to that 30%, but now you should consider, this robot inspection in order to get that area where you couldn't get it before, so that's amazing for me.
Okay. Yeah. So a double win in data density or a win in data density and a win in the access coverage. Inspecting more increases your chance of finding what you were actually looking for. Right. The data density increases that as well and helps you characterize what you just trying to make a call on. That's a double win there for sure. Way I look at some of these technologies as I look at them, like the rapid AUT and the rapid ultrasonic gridding, incredibly complementary technologies. RUG, if you're generalized corrosion or isolated, RUG can be a detection tool for large surface areas. And if you do find something you want to do further inspection with, rapid AUT is the most data rich AUT version out there right now. It's a phased array version of corrosion mapping. They do work hand in hand, I think, really, really well. So I guess, Chase, you already kind of brought this up. When we're talking about environmental cracking, kind of explain to me what you mean by environmental cracking. What are you looking for?
Sure. In respect to, I would put everything in 3 buckets. And so we'll say, you got general corrosion, you have localized corrosion, then you got environmental cracking. But environmental cracking is a really broad term, and it holds many, many buckets of different type of damage mechanisms. Particularly the most common is probably in downstream oil and gas is going to be your wet H2S damage. In respect to that, you need a base metal inspection. You need to be looking close to nozzles and welds. And you also need to be screening the welds for SOHIC. With rapid AET, you can do that base material inspection, but it does not pick up the need for the cracking. So there's been a big push for mechanizing a form of some form of triplex or a technique that's used for HIC-SOHIC with a phased array application to go out and do these large surface areas, get a higher confidence score very, very quickly, and get a really high confidence in that data. And I think we're going to be seeing that here in the near future. Phased array is going to be more commonly applied to these applications for wet H2S damage. Today, it's mostly a follow-up tool to some other method that's robotic, but soon it'll be very common to see that on robotics.
Yeah. So, Jose, what do you see as your metallurgist inspector background? How much opportunity is there to be gained with, not in dollars, but like how much work is out there for a system that can better solve that environmental damage with the HIC, SOHIC, and the blistering and all those things? I mean, I guess HDHA falls into that category as well.
Yeah,
But I guess my question is a little vague. Is that a every site type problem, or is that like just a unicorn type problem?
yeah, for environmental cracking, so what we can actually see with the technology right now, it's like we have a very high density of data, and then if you have that technology there, now you need to support the part of the hardware that you're using to get that. I always mention to make the right calls for clients. So you mentioned HDHA and HIC-SOHIC, so Chase mentioned it. It's very challenging. That even believe it or not, sometimes previous companies or previous, I would say, previous technology, there's still they have some lack of improvement on their technology. So what we're seeing right now, in the short future, is going to be like, it's a game changer, a technology such as phased array and robotics just, merging together in order to increase that confidence of calling right stuff, because, they find some damage mechanism, but the pain point before, it's like they didn't have the expertise or actually the tool to call right stuff on the money. That's actually the product that I've been seeing through my experience, so they can find stuff, but they don't go beyond as far as sizing and categorize those defects as they should do it, because probably the technology wasn't there, but now we do have the technology to go beyond and forward, and critical size those damage mechanisms for them.
Now, if I could cut in here just a little bit, we have a few questions from the audience I wanted to give to everybody before we get deeper into the subject. Now, with this methodology, or with the corrosion mapping or the wall loss damage mechanisms we were talking about, coverage, 100% coverage, is this feasible, and what does this really mean? Is there an assumption on the level of coverage, or is there a default expectation that's made with 100% coverage?
Sure. I can answer that. I think that really relies on, I kind of hinted at it before, but the damage mechanism review. Throughout that process, you're going to identify what are called affected areas that you should be screening on or at for an asset. Sometimes that is done in a manner that you screen the affected area, maybe the whole asset. So a large column, you may screen every weld affected. You may say every weld could be potentially affected, or you may have history from a previous vessel, industry experience, or some other factor to help you determine that it's isolated in a small area, maybe a small region, 10 foot by 10 foot near an inlet or outlet nozzle, restricted flow region, or things like that. All those things will help determine during your DMR where is the affected area. And with that, your NDT service companies are going to go after those potential regions. So it varies. It could be when we're talking about a level A effectiveness and the general guideline is 80 to 100% of the material surface affected area, that could be a whole vessel. That could be a large portion of the whole vessel, or it could be limited to really 20% of the surface area, but you could go to level A for the affected area. So we see that kind of, it's loose, and it's different for every owner user and their confidence, their ability to manage that risk.
Quinn, do you still have that graphic? Because I think I've answered this question before with that graphic as a talking point.
The same one that we were looking at.
Yeah, we just had. So AUT's been accepted. It's a confidence score and a lot of RBI tables for different types of wall loss. It is not a continuous full scan. It's point by point, and it has its overlap, and it has its areas that it doesn't cover. So this is a relatively faster scan. It's on this this graphic here for AUT. It's a 200 thou by 100 thou. So it's a point. It's kind of like a grid. Rapid ultrasonic gridding is a grid, and it's communicated that way by its name, but it's a point by point as well.
Right.
And it can get down to 1/4 inch by 1/4 inch. It actually can do 1/4 inch by about 40 thou. So it's a point by point. It's very, very close to standard AUT. Then you look at this new phased array rapid AUT, it's 40 thou by 40 thou. So your coverage is getting more and more point by point readings. AUT's been accepted as considered 100% coverage or 80% plus based on the RBI tables for A grade on most of these damage mechanisms. Is it truly perfectly 100%? No, but it's been accepted as that for the guidelines. Some of these other technologies, like RUG, is 50 times faster. It's getting very, very close to the same as traditional AUT data density, and rapid AUT is 12x, 9 to 12x. So
If Preston, if I could jump in there real quick, I think it's really important to point out that owner users should evaluate each of these individual NDE technologies for that data density that you spoke of. And even within traditional AUT, conventional UT, corrosion mapping on the far left, we see a really wide gap in what is being done per vendor. So some of the large vendors that are out there, if you go in between each one and see what they're really applying in the field, 200 thou by 100 thou may be a good representation for a couple. And then I've seen others doing a 1/2 inch by 100 thou. So I think it's really important that the owner user, look into what are their actual vendors doing on site, what are their procedures, and then that should really gauge the confidence in those NDE principles, because they're not all the same. Like you said, AUT within this 200 thou by 100 thou has been accepted as something that can fit a level A effectiveness externally. Given that you go out and get the required surface area, the affected area. But I don't think it's being applied the same across the board. And it's important that we look at those NDE procedures and the way that they're being applied in the field.
I do have a follow-up question here, and this is, we've kind of been answering it or touching on it, but I guess in as few words as possible, does this 100% coverage and higher density buy you anything with RBI? And I guess my own question, does it buy the owner user anything within existing RBI confidence tables yet, or do new tables need to come from this? Two parts there.
I think the door is open. I think the door is open for owner users to reevaluate what technologies come around the corner and really address, their confidence in those NDE principles. And I think that's where you got to start. You got to figure out what is the base, that we're generally deploying in the field, and then what is a step above that, and find some common ground between the vendors that they're using. I think it's really important to start there. I don't think it's an even playing field across the board there, and then apply that to the tables. And I think you're going to see a little bit of a variance between the NDE principles alone, and then then we talk about how much surface area that we're going to go grab is another component of that. But you got to start with the NDE techniques and the ability for them to actually find the defects.
Right. And I'm going to add something real quick. Also, the Chase mentioned the area where we're going to grab it, right? So I think the owners have to also work very close with the specialists, because when we've been inspecting those equipment for 20, 15 years, or we can support them in a way to let them choose the right area where they're supposed to have the potential damage. That, for me, that's what I'm seeing the last 15 years. The area they choose for inspection, that 15%, it's not the right area sometimes. So I think, for example, I've done a bunch of RBI inspections, 80 vessels for Higgs-Au Hig, and that some of them are category A or category B, all the way to 95% of the vessel or piece of equipment. But when it's that low percentage, that's where they need that expertise to tell them, to guide them, hey, make sure you got this section, because this section, through experience, I'm pretty sure that you might have something there instead of doing this part, that it probably not. What kind of section? I would say, like, inlet nozzles, I would say hotter part of the exchangers, right above of the impeachment plates, the first tray in a tower, those things, they are pinpoint for vessels, that T-junctions, outlet nozzles. Those are, very critical areas for one vessel, instead of taking those 15%, randomly around the vessel. I think that's also a very good thing that the owner should move forward with.
Yeah, I think the door is open is a good way to put it, Chase. And that's a good way to state it too, Jose. I think if you think about the concept that there's false calls. So there's false calls, people overcall, people undercall, people miss things, just happens. It's the human factors and technology limitations. Well, technology is getting better, which helps the human factors. I'm sure over your career, Jose, you've gone behind people and found things that they didn't find, or they've called something or overcalled something, and you're able to correct that. I think the concept of that existing should be food for thought on reevaluating your confidence tables with the new technologies, because that error is built into some of the confidence factors you have.
Right.
Yeah, of course.
Yeah. So definitely ask some questions if anyone out there has some questions for the group. We got some experts on this, not me, but Jose and Chase and Quinn.
If we could, I know we have some examples of some work where a percentage of the asset has been inspected, where we were able to actually increase the size of the asset that was inspected. Chase, I know you just had a project involving the lower half of the sphere. Could you go into that and how think it's a perfect example of where an automated platform, inspection platform, was able to deliver results far beyond anything else that would have been feasible in that circumstance.
Sure. That's a really good example. The larger the asset is, the more compelling the argument becomes for robotics. So in respect to like spheres, we're seeing RUG go out and do 100% of a typical 45 or 50-foot diameter sphere in 1 or 1.5 shifts, which is, that is a massive tool to go out and screen 100% of a large surface area like that, something like 6,000 square feet or so. That's really, really powerful. Traditionally, if you were to try to do some form of AUT, the typical systems out there being like an ATCO system or something like that is non-steerable. You're going to be out there with scaffold or rope access. You're going to be doing a lot of manual labor to move that robot around. The typical AUT systems I'm speaking of. And you're going to be out there for 30, 40, 50 shifts to accomplish the same goal, or more potentially when you only get about 100 square feet a day. It could be really challenging. So we're seeing RUG as a really good tool to go out there and get, that type of surface area grab really quickly in just one shift. And then when you look at rapid AUT, recently we did one with the bottom third of a sphere, roughly 2,000 square feet or so, I believe, was captured. And it was done in roughly 4 shifts. And we also did an environmental cracking scenario for that vessel as well. And the same rule applies. In roughly 4 shifts, we did 500 square feet per shift on that vessel, grabbing that data for, it was carryover HF issue, but essentially very similar to a wet H2S damage scenario. To do that same thing with traditional AUT, tri-element or triplex method, it would have taken roughly 20 to 25 shifts. So, robotics are really enabling the ability to go to a large production area. And the combination of adding phased array is really just given a really high confidence. We're getting anywhere from 10 to 25 times more data points to do that inspection with, and have a really high confidence in the calls and the data that we're going to have.
Yeah, that's a very good point and good example, Quinn and Chase. I can think of it. Some of the other things that we do a lot robotically that I don't think get done manually because it's just too cost prohibitive would be a flare line. We're running RUG down a flare line with the option of following up with rapid AUT or some of those other technologies. Huge surface areas, access challenges, tank shells, huge surface areas, tank roofs. I mean, most people don't want to be jumping on their roof, their floating roof. So that you can put a robot that weighs 50 pounds with a very light platform and scan your roof. The tank shells, it just crawls up and down the tank shell. The huge surface areas can be covered in a single shift with these type of platforms. I think that's an incredible advantage in a way to look at your RBI program and say, is this now giving me such a higher confidence that I've checked this whole shell? Do I change the way I do business, or I can scan my whole flare line? And before, it would have to be rope access and guys on scaffolding and in doing AUT set by set and take forever. It'd get to the point where a lot of times it'd be so cost prohibitive that it was not a great option. So sampling was done, lower confidence test. So those are the mindsets I think that robotics are going to, or those are the things that are going to change people's minds about how to apply RBI with robotics.
For sure. I see again and again where with the new robotics, it's things like 100% shell scan on a tank. It's something that has always had value, and typically you're taking glimpses at that tank, but now it's well within the means of most budgets to be able to do a large scan like that and to gain all the insights that are inherent to that much data. So it makes it tough to do an apples to apples comparison when there isn't another technology that would even be considered for a job of that scale and at that price point.
Yeah, I know we've done a lot of tank shells where the inspector on site did not expect to find anything. and then we scan it and it's like, wow, there's some corrosion going on here at this this fill level. But and these technologies are able to map out laminations as well. Just that's pretty impressive, I think.
Mhm. For sure. So often we'll go into something looking for one problem and then we'll find something completely unrelated. The laminations you mentioned in the bottom course when we were actually looking for damage relative to the floating roof. So it's very interesting what can be revealed when you have access to those kinds of tools.
Yeah, it's a good map to use if you ever want to put a tank penetration in there and you got to drill into it. You know where the lamination zones might be.
For sure. One of my favorite applications that I've seen, just while we're on the topic of tank shells, would be the CUI inspections on insulated ASTs. You know, if the tank's out of service, then putting a crawler on the wall and running the wall on the inside is a pretty handy tool for finding that CUI without having to remove any insulation. So there's new opportunities and new ways to look at these assets that have got a lot of people excited in the industry.
Yes, that application is pretty cool. The one I think is pretty fun is the ones when we do the roof upside down, with the robot on the roof upside down and running around on the floating roof. But yeah, there's a lot of applications, a lot of different things you can be done with robot platforms, the data density, the data coverage. I think it really is a conversation starter for reevaluating some of these programs to get your back to the same concept at the very beginning. We talked about what is RBI. In my level of understanding, RBI is putting your money into the assets you're concerned about and getting your best bang for your buck, inspection buck, and increasing your safety and your integrity.
For sure.
Anybody have any like concluding thoughts, questions? Please send them in. We have about 10 minutes, but we're winding down.
So I have a question here for using the principles of RBI to scope the work for non-intrusive inspections. Do we have some examples of that we can give that's going to show a good outcome for the owner operator?
Sure. So I think the general limitation lies somewhere in the 220-degree range. We use water as couplet. And because of that, somewhere around 220 degrees, 240 degrees, we have a hard cutoff there in regards to, using water as a couplet. And we, 0-degree corrosion mapping works really well up into those temperatures as well. When you want to go above that, some planning needs to be put in place. There's some things that could be put in place, some hardware configurations, as well as some couplet considerations that we could use different types of couplet to go much, much higher. 300 is very common as kind of a threshold. Somewhere between 220 to 300, things start to open up, and that's kind of more of an everyday. It's challenging, but it is something that can be done regularly. And then from 300 to about 550, other considerations need to be taken into place for hardware and couplet. All those things the door is open to doing those things, but much more planning needs to be done. It's not something that can be done planned for overnight. These are things that with a little bit of prep and a little bit of planning, they can be done. They're becoming more commonplace today. So if that, I think that helps to answer it a little bit, but it's becoming more common, I guess, is the best way to phrase that.
Yeah.
You answered the written question instead of the asked question, but that was an excellent response for temperature limitations and considerations. Because
Yeah,
Sure.
so these problems we're talking about with the general localized pitting, those type of corrosions, your environmental cracking, your environmental hydrogen issues, intergranular issues like HTHA. those are pretty much present at all downstream refining situations. It's hard to do what they're doing without presenting that type of environment to the equipment. So I think it's a pretty big topic.
Absolutely. Another question from the audience here. In your opinions, what would it take for a paradigm shift to occur regarding and improving RBI confidence scores behind these robotic inspection techniques?
Preston, you want to take that one? That's a tough one.
Yeah, definitely. So I think we have a scenario that we all know, and that would be the idea that these new robotic technologies detect something that hadn't been detected in the past with the traditional methods. Whether it is that increase of access advantage, or whether it is that increased coverage advantage, or it's the data density in the format and in producing false calls or overcalls. I think what it's going to take is somebody to get bitten by sticking with the older technology when the newer technology is available and does a better job. I think that's going to shift the paradigm. So when dollars get into the mix because of a mistake, I'm not saying like a mistake through neglect or negligence, but just a mistake of like newest technologies out there, newest industry best practices got better. Not following that, I think that's what will shift it.
I think that is these
Typically safety programs and integrity programs get better after access. That's unfortunate, but that's kind of what normally moves the needle.
I think certainly as we see more and more of these tools in the field, I think that's going to, as the availability of these resources and the awareness of these resources becomes greater within the industry, I think that's going to help to see change for sure. And I think data acquisition is only part of the problem. I mean, it's essential to have engineers that can appreciate these data sets for what they're worth and can establish these confidence tables that ultimately dictate the scope of work for a certain outcome or for a certain requirement in asset combination. So
yeah, and these newer technologies, I think a benefit that we didn't talk about that answers this question as well is it allows for better auditing. So level threes like Jose and Chase can look at this data that's been sent to them. They can look at rug data. They can look at the phased array data and really see a full picture of the job because the data density, the new presentation skills of these technologies really helps with that oversight. And it really helps with second opinions, and it really helps with training. So I think the human factors get better with the new technology as well.
Sure. Yeah.
So we got a question. What is the elevation limit from ground for the robots? There's two limitations. We have the limitation of the rapid ultrasonic gridding platform. We've had Gecko has had tethers that go up to 250 feet. So climbing 250 feet, not our typical tether because there's no reason to carry a bigger extension cord when you don't need it sometimes. But that would be our maximum range for that we've built. Chase, what is the best answer on some of these other phased array technologies?
Yeah, in respect to both technologies, generally we're fighting head pressure on water. So 250 feet or so above, if we can capture water, collect water, get water at the elevation that we're trying to inspect, then we can go much higher. So that's generally our limitation. In respect to phased array, it's the same limitation. We generally have 100-foot umbilicals, and we generally don't have water issues between that 100 feet, but we do have a head pressure issue if we're collecting that water at ground level and we're at 100 feet, 150 feet, and pushing that water up to wherever our actual inspection area is. So head pressure is usually almost always our limitation.
I've used older much older robotic platforms, not robotics, like the first generation stuff on tank shells that had issues at 60 feet. So
Sure.
a lot of engineering goes into that 250 feet.
That's a good question. Yep.
Well, I appreciate everybody for attending. Thank you for the questions. Thank you for your time. Have a good day.
Thank you all.
Y'all.